Thank you everyone for watching this webinar about teaching engineering statistics. My name is Volker Kraft. I'm also with the JMP academic team and based in Europe, in Germany. And in my former life, I was a student in electrical engineering and a researcher in communication acoustics. What means that JMP is really made for us. So JMP, the statistical discovery software from SAS, was launched in 1989, and the first version was really created for the engineer and the scientist in mind. In a nutshell, JMP is an easy-to-use, visual, interactive data analytics package on the desktop, but it comes with a full development environment and can be extended in many different ways. And today, JMP is used by industry and academia worldwide in 6 application areas. And these are data visualization and exploration, statistics and data modeling, quality, reliability, Six Sigma, DOE or design of experiments, market research, and dashboards and applications. And in this webinar, I'm looking at applications which are also taught in many engineering courses. And we will start with summarizing and graphing data and data exploration. Then look into statistics, statistical intervals, and hypothesis testing, and how to build statistical models in JMP. And as some more advanced or special topics, we will also have a brief look into reliability and survival, design of experiments, and also some quality tools in JMP. And before our Q&A at the end, I will also have some goodies to share with you. Today I'm using the Mac version of JMP Pro version 13.2, and if you want to check if you already have JMP, maybe 13, go to the preferences and JMP updates, and there you can see your version, and if it's 13 but not the latest maintenance release, click check now and get it from here. If you're interested in differences between JMP and JMP Pro, I would refer you to the JMP Starter. So here you see the JMP platforms and features in different categories. So if you look at reliability, for instance, you see that some advanced features are Pro specific and JMP Pro only, like reliability block diagram or generalized regression. There's also a category called JMP Pro, and here you can see the Pro specific platforms and also the Pro specific features. That's the JMP Starter you can find in the View or Windows menu depending on your operating system. And by the way, JMP Pro is also included in our site license called JMP Academic Suite. So you get JMP Pro for Windows and Mac for all your faculty, researchers, and students of a department or campus. And if you have any questions about getting a license or academic licensing, please contact academic@jmp.com. And what you see on my screen on the left, that's a JMP journal. And this JMP file, the journal file, will be posted along with a session recording during the next days at jmp.com/webinar. We will send you the link later on. But webinars recorded and also live webinars, these are only one type of resources and content we provide also online. And I would like to refer you for full overview to our online portal at jmp.com/teach. And if you scroll down or go directly to jmp.com/teach on our landing page, There you get access to all the webinars on the left, live and recorded webinars, also some getting started videos. And then the learning library with one-page guides and short videos. You can get case studies from our library with real-world problems and data sets and also solutions, of course. And course material library if you are teaching engineering courses. So here you can check the course collection, bundling all the different types of content and resources we have for engineering quality and reliability. And this gives you an overview about all the different types of resources we believe are really helpful in engineering courses. So that's maybe the perfect place and the starting point if you are considering to teach using JMP. Okay, so let's get started and let's see how to use JMP for summarizing and graphing data. And here I can only show you some examples today, but if you're interested to see more, including column switcher, data filters, or geographic mapping and exporting graphs, you will find more in-depth webinars in our online library. So the first data set I'm going to use, the diameter data set. This can be opened by clicking on the journal link, but it's a data set from our 500 sample data sets shipped with the JMP software, and you find all of them on the help menu under sample data. And some good news, if you just want to play around a bit and see some sample analyses, most of the data sets have some stored scripts in the table panel, the upper left panel in the data set, and you can just click the green triangle and run that script and see some sample analysis to start with. So this data set has 240 measurements of diameter these are the measurements, by the way, one column, and they are measured by different operators using different machines during different phases on different days. And let's get an overview. So how many days do we have here? So you don't need to count or scroll down. What is the maximum, the minimum diameter measured by all the operators? So if you want to just get an overview, a first idea about your data and your variables in the columns in our data set, go to columns and columns viewer. So that's maybe a good starting point here. I choose all our variables and also select to show the quartiles, some other statistics, and then we get this overview here. And diameter, our measurement, so that's numeric data on a continuous scale. And for that we see a minimum and maximum and some statistics. The other variables are all categorical. So here we see that the measurements were probably done on 40 different days using 4 operators and 3 machines. We had 2 phases here. And if I'm interested in more detailed information, maybe the distribution of the diameter values, the measurements, I can select the row, the variable, and then click on distribution to move on with that variable to the distribution platform. But I would like to get there manually because that's also a great platform to start with to explore new data. And you find this platform on the Analyze menu, and it's the first platform called Distribution. So with the data set open, select the platform, and then the process is always the same. On the left you see the variables. So here I take again all of them, and you have to say which role should they play in this analysis. So I'm interested in the distributions for all of them. So there's no stratify or any frequency variable in place here. It's just straightforward, and then when you're done, go by clicking OK. So with the days, that all looks good, but not informative. So I would remove the day output here. And you see that we got different outputs for our variables. On the left side, for diameter, we got a histogram and a box plot and quantile information, summary statistics, because this is numeric data on a continuous scale. Yeah, all the other three variables are categorical, so we only see the levels and then their counts or frequencies. So we see a different output using a bar chart in this case. If you are a JMP user, you definitely know that you can click on certain subsets of data, maybe this operator, and then all the measurements from that operator are also highlighted in all other places, including the underlying data sets. So if you want to compare operators, you see that the operator RMM has a much broader spread of measurements than DRJ, for instance. So this is a bit smaller here. You can also see that this machine was used by all operators and also the other two machines. And all operators were active in all machines in both phases. So that's very easy to check just by clicking and using this dynamic linking feature in JMP, which is pretty unique, I think. You probably also know as a JMP user, if not, don't forget, red triangles are your best friends in JMP. So here on the top level, I could use the red triangle to open a context menu, and one option here is to stack the output. So if you prefer horizontal presentations, in this case, it's done using that option. So there are more red triangles. So here on diameter, for instance, if you're interested in normality, you can add a normal quantile plot. So that's like a toggle switch. You can switch more information on or off. You can also run statistical tests and really dig deeper on the context menus, which are shown as red triangles. Summary statistics, if you want to see more summary statistics, go here and just add them. If you want to add them, if you want to see more by default, maybe kurtosis and variance, you can also do this in the preferences again. So under platforms, you have all the JMP platforms, and here we look at distribution and distribution summary statistics. So I only did a very few changes in my installation. So distribution, I changed just the color, and I really like the separate bars feature here to separate bars on bar charts to make them a bit more different comparing with histograms. And summary statistics, if you want to see some others by default every time and not get them using the red triangle again and again, just select them here and you see that there is a broad selection of additional statistics. Okay, and the second way to work with these interactive reports, the first is the red triangle, of course. The second is a right click. So you can use a right click to change the layout or customize some graphs. You can also sort tables or make a table into a JMP data set, so for further visualization or analysis. So that's all done using a not a red triangle, but the right click, the other option. You also find the simulate and bootstrap feature if you have JMP Pro for most of the statistics on the red triangle. Sorry, on the right click menu. So that's the first example using distributions for exploring new data. For summarizing, there are basically two different tools. One of them is on the Analyze menu, Tabulate. So that's a drag and drop tool for cross tabulation and summary statistics. So let me just start here and then you see how this works. So I just drag and drop a variable and then JMP creates and calculates a statistic, a summary, which is the sum by default in this case. If you want to see the mean and standard deviation instead of the sum, just drop these statistics on sum, and then sum is replaced by the statistics you want to see. And I can move on and then add a grouping variable and drop it on this cell on the row, and then the data and the statistics will be shown by operator in this case. I can also add another one, so you see the little frames which show you where a variable can be added. If I want to use it for grouping, I can do it here, and now it's broken down by operator and then for each operator by machine, or I can also move machine to the left and then it's a hierarchy, but the other way around. So that's very easy to use. You can really create very complex tables, but these are tables. So basically numeric data you see on the tables, and you can add a chart if you like. So if you still prefer some visual output, there's also an option to add a chart as well, available on the red triangle again. Now when you are done, you click done. That's easy. And one generic feature in JMP to save this, to store this, maybe for later use, to come back to this point or to share this with other JMP users. At any place, after some drag and drop, point and click, if you want to keep some report, some analyses, go to the top red triangle and then save this as a script, maybe to the journal or somewhere else, or just to the data table. So I save this to the data table. You can specify a name. This is my tabulate, and now it's added in the table panel at this point here. So now it's easy to run it again and you get back to exactly the same point. And here, if you want to move on and go further, so go to the right triangle, get the control panel back, and then you can maybe add more information here and also the range if you want to see it. Yeah, and then you can move on and change it. So that's saving any analysis, save as a script, maybe to the data table. That's generic in all the places in JMP. The second drag and drop tool, that's on the graph menu, and the platform is called Graph Builder. Oops, sorry, I closed the data set, still needed. So I also want to use it for the second summary tool, but for visual summaries, for visualizations and graphing. And this platform is called Graph Builder. And that's a drag and drop tool. So here you see already some drop zones where you can drag your variables to, and then you can visualize and see relationships and explore your data set. So again, let me show you an example. So I just get diameter and drop it here in the main zone, and then we see diameter on the y-axis and all the points, and it's jittered, just randomly distributed on the x-axis. Now I can look at different operators, so I can check before I release the mouse button. I can see what looks good and what tells me something, and where to use it. Maybe I just drop operator on the x-axis, so now all the measurements are shown by operator, and maybe it's better overview if you switch to box plots, and that can be done by just clicking on an element on the top bar here. I can also add the points again if you still want to see them, and also add more information. Maybe if I want to split this by face, I can have face here or here. That's maybe not a good idea. I can color, just color by the two phases in blue and red, or I can overlay. So now I get two box plots for both phases separately. And if I want to break it down by machine, I can even get, if I drop machine on page, now I get different outputs for the different machines. So that's Graph Builder, drag and drop, very easy to visualize your data, and you get graphs and visualizations. With Tabulate, you get tables, basically. Okay, so let me close this data set now and move on to the next topic, which is about statistical intervals and hypothesis testing. And I'm going to use another sample data set. So this is called thermoplastic .jump. And here we have, if you look at the notes, you see this is about injection molding data from an experiment. And the response is tensile strength. And there are two axes: specific gravity, which is numeric, continuous, and supplier, which is categorical. So again, let us look at distribution. Yeah, so that's a good starting point, as I said, also to explore the data. And then we will look into statistical intervals. In JMP, you don't find any statistical method test or anything on the main menu. So you have to start an analysis on a quite higher level. So for instance, on the Analyze menu, distribution gives you a univariate analysis and descriptions. Fit Y by X is about bivariate analysis, and then you have Fit Model and other platforms for multivariate analysis. And then in a certain context, and if the data type matches, you get the methods and the tests on the red triangles which make sense in that situation, in that context, with that type of data. So you're really basically data-driven in JMP. So here I go into the distribution platform to see this. I take all my three variables in here, and then I click OK. Let me stack this again. So now we see a histogram for specific gravity, another histogram for our response, and a bar chart for supplier, another X. And if you look at let me close these two. So we are mainly interested in our response, tensile strength. And if you look at summary statistics, you see that we already got a 95% confidence interval for the mean, so the lower and the upper bound. So the question is, what if you are interested in another confidence interval, not 95%, but at a different level? And for that, go to the right triangle, not a surprise, I guess, and choose confidence interval, and then you can select. Now that was, sorry, 95% again. No, I wanted to show you another one so that you can see maybe 90%. So now we see the lower and upper bound for a 95% confidence interval. So here you see the 1 minus alpha, 90%. And you see the confidence interval for the mean and also for the standard deviation. So these are the standard confidence intervals, but what about other intervals? Especially in engineering, there are many other intervals used. One of them is the so-called prediction interval, also on the red triangle. And this interval informs you about what can we expect for one or n future observations with a given confidence. What is the expected interval to where they will be? So here that's the confidence, and I'm interested in 10 observations. So 10 future observations. Where are they expected in which interval at a confidence of 95%? This is called a prediction interval, and this gives me the information for all the 10 individual points. So that's the first row here with the lower and upper bound at 95%, but also for the mean and the standard deviation. A third interval is the tolerance interval. So this is about where to expect a certain percentage of our data, again at a given confidence. Still 95%, but where can we expect 90% of our data? So I click go, and then the proportion is 90%, and with a confidence of 95%, we can expect this portion in this interval here, again a lower and an upper bound. So that's about intervals. So there are several options, and they all live in the distribution platform on the red triangle. Let me remove this. The next is about hypothesis testing. So if you want to test for a mean and do a one sample t-test, so where to do it? Yes, it's the red triangle to look at. And here you find an option to test the mean. If you don't, this is pretty clear, I guess, but if you don't, if it's short or if you don't know, so you also get a tooltip which tells you. So this is about a t-test, but it can also be a z-test or even a non-parametric test for the mean. So let me choose this, and I assume a hypothesized mean of 7.2. I could add a standard deviation, a true one, so then it would be a z-test. I could also do a non-parametric test, in this case Wilcoxon signed rank, in parallel, so they typically go together, parametric and non-parametric. This is the parametric test, and we see, so this is our hypothesized mean 7.2 with a sampling distribution for the mean, the blue one, and this is the observed mean here, the red bar. And as you can see from the p-value, so that's the test statistic, but probably greater than, that's the p-value, and this, in this case, the two-sided p-value, and this is highly significant, as you see by the color and the asterisk, so this is significant. So there's some evidence to reject this mean of 7.2. If you want to demonstrate the concept of p-values and hypothesis testing here, there's also an animation called p-value animation. So here you can change the hypothesized mean and make it closer or further apart from the estimated mean, and then you see the p-values also visualized as areas here in the tails. You can even change the sample size and see what the effect is and better understand the concept of hypothesis testing of a mean. So there's another test here. So if you're interested in practical equivalence, if you don't want to test for a difference, but if a mean is equivalent to a hypothesized mean, then you can do this at test equivalence. And here I specify the same hypothesized mean, and I specify what does it mean practically equal. So everything which is smaller than 0.3 is no difference for me in this case. And then there's a confidence level here, and then I click OK. And you get this output for test equivalence, and this is basically, these are basically two t-tests on both sides, and practically equivalent would it be if you can reject both tests on both sides. That's not the case here. So the upper one is not significant. So that's for the lower level, and that means that we cannot conclude that the mean is equivalent to 7.2. Last thing, distribution is fitting a continuous distribution. So you can choose continuous fit and then choose any distribution, or ask JMP to check all of them and give you a ranking. So the winner here is a log normal, which is already added to the histogram. Yeah, and if you're interested in other distributions as well, you can select them. They will be added visually, so they are almost the same here, very comparable. And you can do tests. So for the fitted normal, you can go to the right triangle, and there you find a goodness of fit option. And here we see this is not significant, so small p-values would reject the null hypothesis, which is the data is from the normal distribution. So there's no evidence to reject this assumption with these data. So that's about continuous fitting continuous distributions, and goodness of fit testing. Distribution, the univariate context in JMP. The next step, looking at two variables at a time, fit y by x, 1y, 1x. So let me show you an example here for this one. And as you see on the journal, but also on the launch window, is that this platform can work in 4 different ways. And I would like to show you the first two, these two here, which both use a continuous y, a continuous response. And our continuous response is tensile strength. And the two axes or factors are specific gravity. So that's continuous, continuous. This would be this way, continuous, continuous. And we would get to a bivariate output. And I use supplier as another factor. So now that's this one here. And still continuous response, which would lead us to a one-way analysis. So that's a preview. So here you see the real output. And on the left-hand side, that's continuous versus continuous. So we get a scatter plot. And then on the red triangle, again, you see options. And most of the options are about fitting. So you can fit a mean, you can fit a line. And then the line is added to the data. And you see the equation for the line and also the summary of fit, very low R-squares. Here we see the analysis of variance, and this is not significant at all, and also the slope parameter is not significant. So that's maybe not a way to investigate further. By the way, in the same place you can also ask for correlation. So if you choose density ellipse, maybe 95%, so then you get a graphical representation of the linear association of or between these two variables. And if you go down, you see some numeric output, including the correlation coefficient. So that's for one by one case, continuous by continuous. On the right-hand side, we have continuous by categorical, because supplier is a nominal variable. And on that side, maybe if you have many values and data points, it's maybe a good idea to change the display options and to jitter the points a bit, so that makes it easier to see them. And then the red triangle offers different options. So this is not about fitting as on the left, it's more about means and ANOVA, testing for means and statistical significant differences between these groups here. So I can add quantile information, so you see it graphically, but also numeric output down here. Again, I can ask for means ANOVA, and the ANOVA table already tells us there are no significant differences. So again, an indication maybe not to dig deeper here. So there's maybe nothing interesting to find. So let me switch to another data set to show you some differences, do a similar analysis, but in this case we will see some differences. So this data set, some other sample data, so that's about cleaning tanks, so removing coal particles in this case. So that's our response, our Y, and they are removed at a certain pH value or condition using a certain polymer, A, B, or C. So same procedure, I choose fit Y by X, and our Y, that's the response, still continues. And for the factor, the axis, I choose pH, which is continuous, and polymer as the categorical X. I click OK, and we see the scatter plot on the left. And if we fit a line, now we see, oh, this is significant, and the R-square is much higher. So this fit explains much more of the variation in our data than we saw before. Also, the slope parameter is highly significant. Yeah, so if you think, this looks good, maybe you want to see some diagnostic information, so then check this red triangle on the fit, and then you can plot residual information, and you see the residual by predicted plot. So check if you see some patterns maybe there, you get a normal quantile plot and a lot of diagnostic information. Here on this red triangle for the fit, you can also get a confidence curve for the fit to see where to expect this line at a certain confidence level. On the right hand side, let me add the means ANOVA again, and this analysis assumes equal variance. So if you have just two levels, you would see means ANOVA pooled T on the menu. You also see it down here, standard error uses a pooled estimate of error variance. And in this case, we see, oh, there is some significance. So there are some differences. It's overall significantly different, but the question is where are the differences between which groups, which polymers? And to answer that, you can go to compare means between these groups and then do all the comparisons using a pairwise t-test, and then you get comparison circles, and they can tell you the story about the differences. So if the colors are different, clicking on a circle, so now A and C are significantly different. A is red and C is gray. Here we don't have any different groups comparing with B. So that can be done by comparison circles visually, and then you get all the standard outputs down here, including connecting lattice report, which typically tell you the same story. But this is about multiple comparisons, so you also get other options. So if you want to control the experiment-wide error rate, so you can choose maybe the all pairs Tukey's, honest significant difference, test, and the circles are bigger, so this has less power to detect differences, but in this case we get the same conclusion if we click here or here. So the same colors and similar results down there. There are also other methods. Choose method which compares with the best group, the lowest or highest. And the Dunnett's method they only compare against the control group. So they basically reduce the number of tests you use, and by that the error you could make with multiple tests. And if you want to do a Bonferroni correction, you can also set the alpha level manually here and then choose other, and then you can enter any value for alpha. Okay, so let me move on to the next topic, which is about model building in JMP. And there are different ways to build models in JMP. One is the generic fit model platform. I would like to show you by using some manufacturing data from tablet production. So here the responses are dissolution and locked acceptance. Let me get them up here, so to the left. And dissolution is a continuous response. It's a percentage, and that's the dissolution of tablets in water. It should be higher than 70%. And there's also a binary output. Above 70 is accepted, below is always rejected. So if we look into maybe fit y by x again very briefly, because we missed two cases on the last data set. Let me just show you this before we build a model, multivariate model. Let me look at fit y by x again. In this case, this time I use a categorical response. Yeah, and I check this by screen size. So that's categorical again, and also compressor. And by mill time, which is continuous. And now you see we get the two other options. I mentioned that there are two ways how this platform works. So the one, categorical versus categorical, gives you a contingency table and a mosaic plot. So basically a two-dimensional bar chart here, and more options so to get other measures and tests. In this case, if it's a 2 times 2 table, you also get other options again, including relative risk or odds ratio. You could add on the red triangle. And then number 4, so that's categorical by continuous. Categorical by continuous. Continuous is mill time, our factor. And here we can see the probability. If mill time increases, the probability that a batch will be accepted also increases. So that can be seen by that curve here. So that's logistic regression. Yeah, and you can look at the fit details. You see misclassification rate and other outputs. But again, the red triangle gives you more options. So for instance, our C curve, you want to model for accept, and then you can also see the area under the curve and more information. Okay, so now we move on to modeling, but we will keep the same data set. And to show you the output of the fit model, our generic modeling platform in JMP, I just run this script here, which comes with a sample data set, fit model with interaction profiles. And this gives you the result. By the way, if you run a script from sample data file and you are curious, how was this done? Yeah, so you can always go to the red triangle, open that one, and then redo and ask to relaunch this analysis. And then you see, oh, this was the fit model platform, and you see how this was configured. So we had dissolution or copy of dissolution as our response, and you see that the list of effects and factors was already reduced. So compared to the long list of predictors of factors in our data table. There were only a few used, maybe after some exploratory analysis and a learning curve at the beginning, only the hot axis in here, but also some interactions. So these are the products, and there's also a quadratic term for mill time. And fit model also has a personality where you can choose between different ways to build the model. So this is ordinarily squares, but you can also use stepwise regression, generalized regression, mixed models, and many different ways how to build the model using fit model. So that was the launch window, which led to this output here. And maybe interesting part, the most interesting part to look at after building a model is probably the profiler. And the profiler shows you the factors. So these are the process settings for this manufacturing process. And at certain settings, which are the red values, screen size 3, blend time 14.9, and so on, the model predicts a dissolution of 76% with that confidence interval. And we see the relationships and the traces. So blend time, coating viscosity, so these are linear effects. But mill time, there was a quadratic term. So indeed, we see the curvature and a nonlinear effect of mill time on dissolution. And we see the interactions. So if I change blend time, if you look at the right to spray rate, you see at lower blend time, spray rate has no effect, almost no effect. It's quite flat. But at higher blend time, so spray rate has an effect. It has a steep slope, so it's really significant. And then the story goes further, of course. So now you can ask for optimization, and that's done by adding so-called desirability functions. What do we want? So here this tells you overall we want to maximize. The higher, the better. So as soon as JMP knows what's good, what we want, you can ask JMP to find the best settings to get the best response to fulfill our goal, to maximize. So that's optimization, which can be done automatically. And then you see these are the optimized settings, and we can get a dissolution of 84%. So that's the best what we can get here. There's also a simulator. So if you're interested in robustness studies and to simulate outputs under real-world variation, you can also use the simulator, which is built into the profiler. And when you're done after building a model, if you want to deploy a model under publish prediction formula, so you get to the formula depot. And here you see that you can deploy this model as C code, Python, JavaScript code, SAS code, and so on other systems after building a model in JMP. Okay, so that's just a first idea about model building using fit model. I would like to mention quite briefly, there are also ways for curve fitting and nonlinear modeling in JMP with another data set. So this one here, so there's a relationship, an X and a Y. And if you start with Graph Builder, you see that this relationship is definitely nonlinear. And that's maybe an indication not to use a linear model, but to explore the type of model to use and to do the model fitting in the nonlinear platform. So this is available under specialized modeling. So the first option is to fit a curve. So here I specify my x is x and the y is y. That's easy. So that's my relationship. And now we see the relationship as a scatter plot, and now we can use the built-in models, the model library, and see what this is about. Maybe we can try quadratic model. We can also choose other ones, the fit logistic 2-parameter model. So you can add several models, and then here you see some statistics for comparison, including AIC corrected. But this tells you which model is the winner. So if there's a correct model on this list, so which is the most likely best model, and this is the logistic 2P model in this case. The other one is specialized modeling nonlinear. So here I use my Y again. So that's my response, but the X is a formula. So let me show this here. So we have a formula in the nonlinear column. So this is not static, but this is a nonlinear equation with 2 parameters, B0 and B1. And this can be used now. So I could start and use the model library built into this platform, and then look into a certain model and see if this is maybe a good one to use it, or I use a formula. And here I use the formula for X. We see the formula down here. I click OK. And now we see the starting values for our parameters. And now I can fit the parameters using this model by clicking on Go. And we see that the model converged. And we also see the estimated parameters here for this fit. So that's about nonlinear modeling. And these are the main 3 topics I wanted to show you. So summarizing graphing data, statistical intervals and hypothesis testing, and also model building, including nonlinear models. Unfortunately, we don't have the time to look into detailed examples for the other advanced topics. I just want to mention them. So the first is reliability and survival. So here you can use live data or time to event data, including censoring, which is supported here. And this is some censored microprocessor data. So here we know that the processor was alive between 6 and 12 hours maybe, or units. But here for 6 we know it was still alive at 48, but we don't have an end time. So this is right censored. Yeah, and the question is, can we fit a distribution and can we find a model for these data? And this is one of the platforms from the survival and reliability menu. And the event plot shows you the situation, including the censoring, and you see what we know. So here the 122 times. So we knew it was still alive at 2000, the time 2000, but we didn't know what happened afterwards. So right censored. So here we have an interval. So that's the event plot. And taking all the data together, not omitting or removing any censored data, but use it for model building. And then you can use the compare distributions tool to fit distributions. So one is non-parametric, so this leads you to the Kaplan-Meier curve, but you can also look at certain distributions, log normal or Weibull, and also change the scale. And then if all the data points follow a straight line, then it's probably a good fit. And you can also ask JMP to check the distributions and find a good model, a good distribution for these data. And here we see that the Weibull is indeed the best one from this ranking. And then you can go down to the Weibull case, and here you get a profiler again. So we can see that after 15,000 time units, there's a probability of 2% that a unit will be failed. So that's live distribution, just one option under reliability and survival. For design of experiments, this is really a very important topic, especially in engineering on its own. So I don't have the time to show you an example today, but I would like to invite you to our webinar in November. That's on November 14th, and that's about teaching DOE using JMP, and there you will see examples of our custom designer, definitive screening design, so modern ways to design an experiment. And JMP is really a leading package here, and it's definitely worth to check it out if you don't know it already. And the third group of tools include process and quality tools. So just one example here. So quality statistical process control. This is again the diameter data set. And if you're interested in stability, maybe you want to look at a control chart, and again that there's an interactive tool, so you can just drag and drop diameter in here. That's on days, so now it switches automatically to an X-bar and R chart, and you see the control limits, and I can break it down maybe by phase. Yeah, and there are also tests built in, so you can test for special courses. So do all tests, and we see here that there's an alarm, and here's an alarm, 4 out of 5 points in a row beyond 1 sigma. So that's a nice way to build control charts interactively. But you also find all the control charts on the quality and process menu under control charts. Other options we don't have the chance to look into. What about stability? That was the control chart, but what about capability? So if you have specification limits and external requirements, customer requirements, then you would probably look into the process capability platform to see how capable your process is. And you can also do this for hundreds or thousands of processes, and there's a goal plot which can give you a nice overview for a high number of processes to see which ones are good and which ones need some attention. And at the beginning, you should always check your measurement process and measurement systems, and for that we also have different ways in JMP to explore this further, including EMP, the Wheeler's method, evaluating the measurement process. But this really tells you where the variation is coming from. You see, you typically want to separate parts, but you don't want to see a lot of noise created by the measurement system or by operators or the measurement process. So that can be tested in the first place before you move on to testing stability and capability. And to learn more about that topic, go to the help menu, and there you find books. And one book is about quality and process methods, and that's the last topic. But there are also books about reliability and survival, and a book, maybe 700 pages, about design of experiments. And for all of these topics, we also have more dedicated and specialized webinars. Check our academic webinar series for special topics, or maybe Mastering JMP on our webpage. So we are done already. So I mentioned some goodies. You will get an email, and that will give you a link to download this JMP journal. And you can use the journal to get to 3 links. One link leads you to the Faculty Resources Center for Engineering Statistics, and that's a good starting point, and you can find some interesting information here. Another goodie is a sample chapter you can get for a brand new book, and that's called Problem Solving for New Engineers, what every engineering manager wants you to know. So that's a book I really recommend. It's a very nice read, and I think very important today, and you can get a free chapter using that link. And the third, Industry Speaks, so this gives you some voices from industry, from the world outside, telling you what's important for students to learn, what should they know, which skills are required for engineers of the future.